Hi again. I'm glad to see you here. This video is on tracing a recursive function that we wrote in the previous video. Here's the code that we wrote in the previous video. The name of the class is recur. That means my file name is recur.java. I'm calling my recursive method test that prints n consecutive non-zero numbers starting from n in descending order. Here actually in this example n is equal to 5. This part is the base case. And this line is basically the task assigned to this particular method, and that task is just printing one number, the one number that came in as the parameter. And this line is my recursive call. In this recursive call, I'm doing the rest of the tasks, that is printing all the numbers other than p. Let us trace this code with n equals 3 instead of n equals 5 for simplicity. Notice that I am passing 3 as my argument to the method named test. When the execution goes to the method p is equal to 3, the first line is executed. The first line contains the condition for base case if p is smaller than or equal to 0. Since p is not smaller than or equal to 0, the execution jumps to the line with system.out.println p. P is printed. P is equal to 3. As a result, on the terminal you'll see 3. The next line has the recursive call with a parameter of p minus 1. That is, in the recursive call, the parameter is going to change from 3 to 2. A recursive call is always considered as a separate method. You can consider that you are calling another method that has the same name test, but the incoming parameter is different. In this case, the parameter is 2. With p equals 2, you check the base case. P is not less than or equal to 0. Therefore, the execution jumps to system.out.println. You are printing p, which is currently 2. 2 is printed on the terminal. Now you are calling the same method test with p minus 1. 2 minus 1 is equal to 1. Therefore, 1 is passed in this recursive call. When we go inside the method with p equals 1, the base case is still not reached because p is not less than or equal to 0. The execution point jumps to system.out.println. p, which is now 1, is printed. We have 1 on the terminal. After printing 1, we call the same method with 1 minus 1, that is with 0. We are inside a method which has p equals 0. In the first line, we are checking if p is smaller than or equal to 0. Yes, p is 0. Yay! We go inside the curly braces. This is the first time we have reached the base case. The statement inside is return, so we return to its caller method. With a return statement, the execution always returns to the caller method right after the line where we left it. After returning, the method we have returned from is not accessible anymore. Now notice that we are at the end of the method with p equals 1. We do not have anything else to do in this method. Therefore, we return back to its caller method. Again, when we return, the method we have returned from is not accessible anymore. We are back to the method with p equals 2. Nothing else to do in this method. We return to its caller. That is, we are currently back to the method with p equals 3. We do not have anything else to do in this method. Therefore, we return back to its caller, which is the main method. In the main method, there is nothing else to do. Therefore, the program terminates. Notice that you have the three numbers 3, 2, 1 already printed on the terminal. Printing three numbers is just a practice. As I said in the previous video, recursion is not ideal for such a simple task. We will see complex examples in the class. Until then, do some practice like printing some n numbers in ascending order starting from 1 using recursion, or something like printing the first 50 positive odd integers using recursion, so on and so forth. I hope this tracing was helpful in clarifying how recursion works. Let me know if you have any question. Have a wonderful evening, morning, or night. Anyway, whatever part of the day you are watching it.